In the previous video, we discussed the basic concept of parametric equations and parametric curve. So basically for a rectangular equation, you have y equals to x squared, right? So you have a parabola. So when you use rectangular coordinate, you have two variables, x and y, right? So every time you graph that x and y, the x and y tells you where the point is on the picture. Again, the x comma y, that x and y coordinate tells you where. So the word where is a location, where the point is. But one thing that comes into my mind is, let's say we have a particle travel along a path at a time equals to 0, time equals to 1. How do you tell me the location of a point when time equals to a specific value? So using rectangular coordinates, we can't do it because x and y only gives you the location. It doesn't give you a time. So that means behind the scenes, so behind x and y, we have to say that x is determined by some parameter t. So x is determined by a time and y is determined by a time. So in this video, I will give you a formal definition of parametric curve, which is called a plane curve, and then I will show you how to convert a parametric equation to a rectangular equation. So if you look at the yellow parametric equation, x is equals to some t, y is equals to some t, right? So x comma y, the rectangular coordinate, is only a location where the point is, right? It doesn't tell you the time. All right, so we behind the point x comma y, so we have to dive one step further. X can be explained by some t, y can be explained by some t. So that means the x value and the y value, or you say the x coordinate and the y coordinate, they are determined by the parameter t. The t stands for time. All right, so how do you convert parametric to a rectangular? Parametric is a set of equation, right? We use one parameter t to link a few equations. So that is x equals to some t, y equals to some t. After you make the conversion, we will have x equals to some y. All right, so we first of all, let's take a look at this formal definition. If f and g are continuous functions of t on an interval I, then the equations x equals to some t, y equals to some t, they are called parametric equations, and t is parameter, the set of points x comma y obtained as t varies over the interval I. So as the time changes, the location changes. Over the interval I is the graph of the parametric equation. So we are using one graph to describe how the x and y changes, how the location changes as time changes. So this graph, this path is called a parametric curve. And then the equation is called parametric equation. So taken together, the parametric equation and the graph are a plane curve denoted by a big C. Plane curve means parametric curve. So the x equals to some t, y equals to some t is a parametric equation, and then the curve of that, we call it a parametric curve. So in the first example, I have a set of parametric equation and I gave you the interval of t. What I want you to do is, I want you to graph this parametric equation. So the way we do it is, we are going to choose some t first. So this one, I have t goes from -2 to 3, right? How about this? -2, t equals to -1, t equals to 0, t equals to 1, and t equals to 2, and t equals to 3. So we need to plug the t into the function. So what is x equals to? So x is equal to -2 squared, right, minus 4. So x is equals to 0, and y is equal to 1/2 times -2, that equals to -1. So we have a point. Let's put a point right here, 0 comma -1. So this is x comma y is a location. And then this one, we have a -1 squared minus 4. So that is a -3. And then this will be a -1/2. So we have a -3 comma -1/2. And then a 0 square minus 4, we have a -4. This is only a 0. So we have a -4, 0. And then 1 square minus 4. And then just a 1/2, right? So we have a -1/3 comma a half. Not a -1/3. -3, and then 2 squared minus 4 is equals to 0. 1/2 times 2 is equals to 1, and then we have a 0, 1. They must be in order, and the t must be in ascending order. Ascending order means you go from the smallest possible t to the biggest possible t. And then when t is equals to 3, we have 3 squared. 9 minus 4 is equals to 5, and then 1/2 times 3, so this is a 3 over 2, so that we have a 5, 3 over 2. So we have how many points? We have 6 points. Let's graph these 6 points. Okay, x-axis, y-axis, keep them straight. So that is x, and then that is y. So we have 0, negative 1. So 0, negative 1. So 0, negative 1. So that would be this point right here. And then negative 3, 1/2. So negative 3, negative 1/2 is like right here, right? We don't want to go all the way to the left because we still have a negative 4. So negative 3, and then negative 1/2. Let's put this in a more fair location. Negative 1/2. Don't like that. There, here. And then negative 4, 0. And then negative 3 past the 1/2, which is right above that. 0, 1. And then we have 5, 3/2. So 5, 3/2 is supposed to be right here, right? So what is the order? The order is we go from just look like a parabola, right? So first we go to the left, and then we go up, and then shoot back to the right. So here is the order, just like a parabola. And what else is missing? The direction. We don't use the word direction, we use the word orientation. So the particle, this little point, travels along this direction. So this is called a parametric curve. And then what is my parametric equation? My parametric equation is x equals to t squared minus 4, y is equals to 1/2 t, and t is in the interval from negative 2 to 3. And then this is my parametric equation. So I got my parametric equation, my parametric curve. What about the rectangular equation? How do I go from parametric back to rectangular? It's not a tough job. You don't need derivative or integral. It's some simple math. So again, we have x equals to t squared minus 4, and y is equals to 1/2 t. So first we change that to multiply 2 on both sides. We have 2y equals to t, right? So 2y is equals to t, and then I will plug in the 2y to here. So that means we have x equals to 2y squared minus 4. So we have x equals to 4y. I'm going to put it right there because I want to give you a graph too. So I have x equals to 4y squared minus 4. Can you tell me what the graph looks like? You are not supposed to be using a calculator for this function. So the graph is a sideways parabola, right? So if you have a 4y squared, so the parabola looks like this. And then with the minus 4, you have to shift the vertex 4 units to the left. So 4y squared minus 4, 4y squared minus 4 equals to x. The graph looks like this. This is x equals to negative 4, and then we have this graph. And then where is my rectangular equation? So this is my x equals to y squared minus 4 is my rectangular. Equation. So in this video, we just define the definition of parametric curve, and then I also introduce how do you sketch the graph of how do you sketch up the parametric curve of a parametric equation, and then how do you go from parametric back to rectangular. So that will be the end of this part. If you think my instruction is helpful, please like, subscribe, and share. I appreciate your help really much. Signing out for now. I see you in the next video.